Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video I will be solving the paper 4 exam for May-June 2022, variant 1. Question 1 says, a car of mass m is traveling along a straight horizontal road at a constant speed v. At time t equals 0, the driver of the car sees an obstruction in the road ahead of the car and applies the brakes. The car does not begin to decelerate at time t equals 0. Explain what is meant by deceleration. It is the rate of decrease of velocity. Question B says, suggest one reason why the car does not begin to decelerate at time 0 due to human reaction time or reflex time. Question I says, state the property of the distance time graph that corresponds to speed. That would be the gradient of the graph or the slope of the graph. Double I says, using figure 1.1, determine the initial speed v of the car. So we use the equation for gradient y2 minus y1 over x2 minus x1. We can use this point here as point 1, 0 and 0. We can also use this point which is at 16 and 0.7. So we can use these numbers as 16 minus 0 over 0.7 minus 0. That would give an approximate answer of 23 meters per second for speed. Question D says, when the car is decelerating, there is a constant resistive force F on the car due to the brakes. The deceleration of the car is greater than F over m and is not constant. Explain why the deceleration of the car is greater than F over m. This means that there is another force other than F, which could be the air resistance. So we can say there is air resistance against the motion. So it adds to the total force opposing the motion. The deceleration is not constant. Why? Because air resistance depends on speed. As speed decreases, air resistance decreases, so resultant force and acceleration decrease. We can say acceleration or deceleration in this part. The next question says, figure 2.1 shows water stored in a reservoir behind the hydroelectric dam. State the form of energy stored in the water in the reservoir that is used to generate electricity. That would be gravitational potential energy. B says a turbine is 150 meters below the level of the water in the reservoir. Atmospheric pressure is 1 times 10 to the power 5 Pascal and the density of water is 1000 kilograms per meter cubed. Calculate the total pressure in the water turbine. Calculate the total pressure in the water at the turbine. So the total pressure would be equal to the atmospheric pressure plus the pressure due to the liquid, which can be calculated using rho gh. So we have 1.0 times 10 to the power 5 plus 1000 times 9.8 times 150 as depth. This gives an approximate value of 1.57 times 10 to the power 6 Pascal. BII says the turbine has a cross-sectional area of 3.5 meters squared. Calculate the force exerted on the turbine by the water. We can use the equation force equals pressure multiplied by area, or pressure equals force over area. Then we multiply 1.57 times 10 to the power 6 by 3.5, which is the area in meters squared, so we do not need to convert it. This gives a value of 5,495,000, which we can approximate to two significant figures according to the question. Significant figures. That would be 5.5 times 10 to the power 6 newtons. Part C says the water flows to the turbine through a pipe of constant cross-sectional area. Explain why the kinetic energy of the water in the pipe remains constant as it flows through the pipe. This means that the water moves with constant speed, since liquids do not change volume at constant temperatures. So in order to move faster at any part of the pipe, gaps would be created or bubbles would be created. So one part would not have any mass or have any kinetic energy since kinetic energy is calculated as half times mass times speed squared, those bubbles or those empty spaces would not have any mass and have no energy. And the rest of the energy is converted to heat due to friction or to sound. The next question says, during a picnic on a warm, dry day, a metal can of lemonade is wrapped in a damp cloth. Evaporation cools the water in the cloth. Explain in terms of molecules how evaporation cools the water in the cloth. So the most energetic water molecules absorb energy by conduction from the cloth to escape. That's evaporation, leaving the molecules of the cloth with lower average kinetic energy. That's why temperature decreases, because the kinetic energy of the molecules decreases. Part B says, as the water in the cloth cools, so does the lemonade. Explain how electrons transfer thermal energy through the metal of the can. So we can say that as atoms or molecules gain kinetic energy, they vibrate faster and collide with the adjacent atoms, giving energy to the free electrons to move from atom to atom. The main concept here is using free electrons and saying that it is transfers from atom to another atom or between atoms due to collisions or due to gaining kinetic energy and vibrations. Next question says, a thermocouple is a device that is used as a thermometer. This part you can skip for the new syllabus since thermometers are removed from the syllabus. Part A says, figure 4.1 shows a beaker that contains molten sulfur at an initial temperature greater than 400 degrees Celsius. On figure 4.1, sketch and label a diagram of a thermocouple that is used to determine the temperature of the sulfur as it cools to room temperature. So we have here a voltmeter with two wires, and at the ends of the wires we connect another wire, and we call this the hot junction and the other one the cold junction. And the cold junction should be immersed in pure melting ice, so we can draw something like that and we label it pure melting ice. These two wires should be made of the same metal, so we can label it metal 1, and the other wire should be labeled with another metal, so we can label it metal 2, or you can actually use names of metals like copper and iron, aluminium and tungsten, or whatever. Double I says, describe briefly how the temperature of the sulfur in the beaker is deduced. The voltmeter reads a potential difference when there is a temperature difference between the junctions and is calibrated to read temperature instead of potential difference or voltage. Part B says, state one advantage of using a thermocouple to measure temperature rather than using a liquid in glass thermometer. It has a higher range, or it can reach higher temperatures, and it is less fragile. The next question says, figure 5.1 shows a kitchen tap that supplies instant boiling water. Cold water passes over an electric immersion heater inside the tap. The boiling point of water is 100 degrees Celsius. Part A says, state what is meant by boiling point. It is the temperature at which liquid turns into gas. Question B says, the immersion heater is powered by the mains at a voltage of 230 volts. When the tap is opened, the heater switches on and the current in the heater is 13 amperes. Calculate the thermal energy produced by the heater in 60 seconds. So we can use the energy equals power multiplied by time, and the electric power can be calculated as voltage multiplied by current. Then we multiply that by time. So we have 230 multiplied by 13 multiplied by 60 seconds. We need it in seconds, so leave it as it is. This gives an answer of 179,400. So we can approximate that to two significant figures as the numbers in the question, to 1.8 times 10 to the power of 5 joules, Double I says the specific heat capacity of water is 4,200 joules per kilogram degrees Celsius. The cold water that enters the tap is at 22 degrees Celsius. Then it is heated to 100 degrees. Calculate the rate at which water at its boiling point emerges from the tap. So rate of water, that means mass divided by time. So we have the equation Q equals mc delta theta, or PT equals mc delta theta. So we need mass divided by time. So we can move the time to the other side by division, and we move these to the other side by division. We will have power divided by C delta theta equals mass divided by time, which is required here. So we can say that the rate is equal to the power, which is 230 multiplied by 13, then divided by the specific heat capacity, which is 4,200, multiplied by the difference in temperature, 100 minus 22. This gives a value of 0.0091 kilograms per second, mass divided by time, or we can convert it to grams. That would be 9.1 grams per second. Part C says the metal tap is earth and there is a fuse in the cable that connects the heater to the mains. Explain how the earth wire protects the user if the live wire touches the metal tap. A large current passes to earth and the fuse blows or opens the circuit. Part 2 says explain how the fuse protects the circuit. Also, if the current gets too high, it can damage the circuit. The fuse disconnects the circuit, which is a little wire that melts and then opens the circuit. The next question says figure 6.1 shows a road next to the sea. On a sunny day, the sun warms the road. Describe how energy from the sun reaches the earth and warms the road. So first we say that heat is transferred by infrared radiation through space and then absorbed by the molecules of the road, causing their kinetic energy to increase. That's why the temperature increases. Part B says the temperature of the road is greater than the temperature of the sea. The surface of the road is black. Suggest one reason why the temperature of the road is greater than that of the sea. Because it is a better absorber of infrared radiation or heat radiation. Part C says the air above the road is heated by the warm road. Describe how this affects the molecules of the air. So air expands and becomes less dense as molecules move further apart. That's why hot air rises. Part II says a cyclist traveling along the road notices that a cool breeze is blowing from the sea to the land. Explain how convection produces this breeze. You may include a diagram if it helps your answer. So if this is the land and this is the sea, so we have hot air here above the hot road, and this hot air rises and the cold air or cool air from above the sea replaces it, and colder air from above the sea falls down, and the cycle is completed like this. And we can say that hot air above the road rises and cold air above the sea replaces it due to convection current, as shown in the diagram. The next question says figure 7.1 is a full-scale diagram of a small nail N in front of a thin converging lens. The line L represents the lens, and we have each 5 small squares represent 1 centimeter on the graph. The focal length of the lens is 3.0 centimeters. Rays of light parallel to XY are traveling towards the lens. Describe what happens to the light after it passes through the lens. So the rays that are parallel to the principal axis go towards the focal point or the focus after the lens. So we say that all rays bend towards the focus, then diverge after the focus. So they are all moving in this direction. So the one on the principal axis goes on, the others meet at the focal point, then diverge afterwards. Part B says, on figure 7.1, mark and label with an F each of the two principal focuses of the lens. So it said in the question that the focal length is 3 centimeters. So we have 1, 2, and 3. So this is the first focal point. And we have 1, 2, and 3. So this is the second focal point. Part C says a small nail N of height 1.2 centimeters is positioned 2 centimeters to the left of the lens. By drawing on figure 7.1, find the position of the image I of N and add image I to the diagram. So we go to the top of the nail and we draw 2 arrows, one that is parallel to the principal axis and then goes to the focal point. But in this case, the object is in between the focus and the lens, so we should extend the line backwards as far as we can. The other arrow is from the top of the nail to the central point or the optical center, and we also have to extend that backwards to find the intersection point. So the intersection is approximately at this point, and we make the extensions dashed lines since these are not the actual rays of light. We just extended them to find the position of the image. Then we add arrows to the rays of light just to indicate the direction of the rays. Then we are required to draw the image, so we can draw just a vertical line to represent the length of the nail and the base of the nail, which should be enlarged like this. And it said in the question to name it I, to name the image I, so here it is. Part double I says, state and explain whether I is real or virtual. It is virtual since it is made of extensions of rays, or the light does not actually pass through this image. Part triple I says, state the name given to a lens when it is used in this way. That would be a magnifying glass or lens. The next question says, figure 8.1 shows 2 vertical cylindrical tubes and the cylindrical magnet all held in a vacuum. One tube is made of plastic and the other tube is made of copper. The 2 cylindrical tubes have identical dimensions. The magnetic field of the small cylindrical magnet is extremely strong. Initially, the magnet is at rest at the top of the plastic tube. The magnet is released and it falls through the plastic tube without experiencing a resistive force. The magnet takes 0.67 seconds to fall to the lower end of the plastic tube. Question A says that the mass of the magnet is 0.012 kilograms. Calculate the kinetic energy of the magnet when it reaches the lower end of the plastic tube. So we need to find the speed at first. So we can use the equation V equals U plus AT to find the final velocity. The initial velocity was 0 since it started from rest, and the acceleration is equal to the gravity acceleration. Then we multiplied by the time, which is 0.67 seconds. We have an approximate value of 6.566. So then we can use the kinetic energy equals half mv squared. So half multiplied by 0.012 multiplied by the answer on the calculator squared. That gives a value of 0.26 joules. Part B says the magnet is then held at the top of the copper tube and released. As it falls through the copper tube, an electric current is generated in the copper. That's due to electromagnetic induction. Part I says explain why there is a current in the copper. We say as the magnet moves, there is a change in flux in the tube, or we can say that the magnet cuts the tube or the tube cuts the magnetic field, which induces an EMF, which is voltage, which then induces current. Part double I says the current in the copper produces a magnetic field of its own in the tube. The magnet falls much more slowly in the copper tube than in the plastic tube. Explain why the magnet falls more slowly in the copper tube. So the field, due to the induced current, opposes the motion of the magnet, or we can say that it creates a resistive force upwards against the motion of the magnet. This is according to Lenz's law. The next question says combinations of logic gates are used when digital signals are processed. Describe the difference between a digital signal and an analog signal. You may include a diagram if it helps you. So we can draw an analog signal that varies continuously like this, taking any value, and a digital signal only has specific values, so we can use these levels as discrete levels. And then we can say that analog signal or signals vary or change continuously, but digital signals have discrete values or have only two values for binary digital systems, which is high and low. Part B of this question is about logic gates, so you can skip it for the new syllabus. It says figure 9.1 is the truth table for a logic gate X. State the name of the logic gate X and draw the symbol that represents it. So we have here anything that contains 1 gives an output 0, except 0 and 0 that gives 1. That would be the opposite of an OR gate, which is a NOR gate. And the symbol for a NOR gate is like this. And we label this the output and these two the inputs of the gate. Part C says logic gate Y is identical to logic gate X, so we have two of these. Draw a combination of logic gates X and Y that behaves like an OR gate, so we need to reverse the NOR gate. There is a trick about NOR gates or NAND gates. If you connect the two inputs, it acts as if it is a NOT gate. So we can connect the two inputs, make them one input, that's a NOT gate, and we have the NOR gate at the input. So now we have an OR gate. It also says label its inputs A and B, so these are A and B, and the output Q, so this is Q. The next question says two of the isotopes of hydrogen are hydrogen 2 and hydrogen 3. State one similarity in the composition of their nuclei, same proton number, or both have one proton. Describe how a nucleus of hydrogen 3 differs from a nucleus of hydrogen 2. We can say that hydrogen 3 has 2 neutrons, hydrogen 2 has 1 neutron, or that hydrogen 3 has 1 more neutron than hydrogen 2. Part B says in a nuclear fusion reactor, a nucleus of hydrogen 2 fuses with a nucleus of hydrogen 3 at an extremely high temperature. This fusion reaction produces an isotope of element called X and releases a neutron. Explain why an extremely high temperature is needed when forcing these two nuclei together. Basically because nuclei are positively charged and repel each other, so they must have high initial kinetic energy when directed towards each other, because the repulsion would cause the kinetic energy to decrease as they approach each other until they reach and combine. Part II says using nuclide notation, complete the equation for this reaction. So we had the hydrogen 2 and hydrogen 3 at first, then we had an element X and a neutron according to the question. We should remember that a neutron has a nucleon number of 1 and proton number of 0. Then we try to balance the numbers at the tops. So here we have 5. So 5 minus 1 equals 4 at the top. And at the bottom we have a total of 2. And here we have 0. So it's 2 at the bottom. Which are the numbers for an alpha particle or a helium nucleus. So this was the end of this exam. I hope you found this video useful to you and enjoyed it. And I will see you in another video.